Alright, let's up the ante. We've done a lot of solving one-step equations. Let's look at equations where we want to solve for our unknown, but actually have two steps to do in the process. So often that involves adding and multiplying, or subtracting and dividing, or things like that. So let's take a look at what we got here. I have some value, x. I don't know what it is. I'm going to solve for it though, but it's being multiplied by 3. I subtract 5 from it, and the result is that I end up with 28. So I need to solve this out. Again, my goal is to do things to both sides, and I want to know, well, what does x have to equal to make that equation true? All right, now let's think about solving this out. Again, in solving equations, I know essentially the solution. I know it should equal 28, and so I'm trying to work backwards to figure out, well, what is that number x that I start with to get to 28? So when you get more and more complicated equations, sometimes you have to think, well, what do I do first? Do I subtract? Do I get rid of the 5? Do I get rid of the 3? What's the right order? When we get into more complicated equations, it gets even more complicated. So here's how you kind of know, help you guide the order. If I was to evaluate it, what I know is I take x, in my order of operations, if I knew what x was, the first thing I would do would be to multiply by 3. That's the first step, I do all my multiplying and dividing before I do any subtraction. Once I took x, multiplied it by 3, then I would subtract 5, and the result is that it would equal 28. So that's kind of the order of operations. Start with the number x, whatever x is, and I can see that I should end up with 28. But we're going backwards. We're trying to solve this equation, right? So I'm working with the fact that I know what 28 is, but I'm trying to solve for what x is. So I'm starting with, I know 28, I know my steps, I need to undo and eventually figure out what x is. So let's think about this then. If I'm working backwards, the first thing I need to deal with is this minus 5, right? I know I have 28, so I want to first get rid of the minus 5. So to do that, we already know the opposite of subtracting 5 is to add 5. So I'm going to add 5 to both sides. Now I've got 3 times x minus 5 plus 5 on the left, and I've got 28 plus 5 on the right. Well, let's simplify some things here. Minus 5 plus 5, that all turns into 0. And so I just have 3 times x equals 28 plus 5 is going to be 33. All right, so we started with 28. We've dealt with the negative 5. And now we can deal with the multiplying by 3. Now it becomes a one-step equation. I love it. This is much easier to solve. 3 times a number, well, I want to divide by 3. I just want to know what the 3 is. So the opposite of multiplying by 3 is to divide by 3. Do that to both sides to keep things equal. 3 divided by 3 is 1, so I have 1 times x. On the right side, 33 divided by 3 is 11, so it looks like my solution is that x equals 11. All right. Let's check our work real fast. Does 3 times 11, I'm putting that in place of x, minus 5, does that actually equal 28? 3 times 11 is 33. Now I'm working forwards, right? Taking x, times it by 3. 33 minus 5 is 28, so it all checks out. Okay, so going back, doing some quick review, in my equation, whenever you have a two-step equation, since we're working backwards, we do the order of operations backwards. I want to get rid of adding or subtracting first, and the last step is to deal with whatever's in front of x. So I got rid of the minus 5 by adding 5 first, and then I dealt with the multiplying by 3, and I got rid of it by dividing by 3. All right, hopefully that was a good, helpful example for you in solving two-step equations.